Problem number 48, we just not only have to find the relative max and min, but we also have to find the zeros for the function. And we are going to go ahead and draw just an x and a y axes here, x and y axes. And well, let's see what the graph looks like. I already typed it into my y equals. If you want to know how to do that, watch one of the other two videos because I show that. Oh, nice. We only have one x-intercept, and we can see clearly, since we already knew that the graph would look like that, since it's a third-degree polynomial and a is positive, that it has to go up from left to right, and the ends of the graph are going to go in opposite directions. And so we can go ahead and draw this. It looks like the high point is going to be at 0, -3, so it looks like that, and it's going to come down. It's going to go up between 1 and 2. So it's going to come up here, and it's going to go down, and it's going to go up like that. So this point right here is what we call our relative max. And then this point right here is called our relative min. And the relative min is the lowest point of the ones right around it in a small neighborhood. Relative max is the high point in the small neighborhood. And this guy right here is our 0. So we're going to list the coordinates of the 0, and we're going to list the coordinates of the relative max and min. And to find the relative max, we do second trace, scroll down and hit maximum, and then enter, left bound, move the cursor to the left. You know, what I'd like to do here is I'd like to see it a little bit better. And so I'm going to let my x min be -5 and my x max be 5. And then let's see how that looks. So it'll give me a little bit nicer look. In fact, I could go out to -2, so -2. And then I always want to make sure I change my x-res to 3 because it takes forever. So there, it just opens it up a little bit. Second, calculate max. And then left bound, -1. Right bound, 1. Enter. That's the fast way to do it. And then move the cursor back there a little bit. And oh, I guess it wasn't exactly at 0, -3. So the relative max then would be at -0.047, comma, -2.976. -2.976 for the relative max. And then we do the same for the relative min. Type a 3 for that. We're going to go 0.2, and then we'll go 2, and then guess 1. And we have the relative min, then I'm going to move this over a little bit, 0.881 for the relative min, 0.881, comma, -6.172, -6.172 for the relative min. And then the 0, we haven't done this in either of the other videos, so I'll take a little time on this. Second trace. Now, it's an x-intercept, it's called a 0, it's called a root. All of those mean the same thing. It's where the y value is 0. So we want to calculate the 0, or the coordinates of the place where the graph crosses the x-axis. The left bound means that the cursor is to the left horizontally of the x-intercept, of the 0. If we move the cursor up there, the cursor is actually to the right of. Now, when we think of this in terms of left of and right of, the x-intercept is right there. The cursor being there means it's on the right-hand side. The cursor being over here means it's on the left-hand side of that x-intercept. So we're going to mark that with an enter. And then we just want to, again, surround the x-intercept with 2 vertical lines, noticing that the graph crosses the x-axis in between these 2 vertical lines. We can put the cursor anywhere in between those 2 vertical lines and hit enter. And we get our x-intercept, or the 0, of 1.5, 0. 1.5, 0. We can put the coordinates of the 0, or y has a 0 at x equals 1.5. You know, any of that, any way to say that, you can list the coordinates or you can write it like that. And that's it.